Microsoft's recall feature was introduced as a bold step into the future of personal computing. Marketed as an AI-powered memory system, it promises to capture snapshots of a user's activity across their Windows device, making it possible to search and retrieve virtually anything they have seen or done. In theory, it sounds revolutionary. Imagine being able to recall a web page you visited weeks ago without remembering its URL, or retrieve a conversation fragment from a chat window simply by describing it. It presents itself as a digital extension of human memory. Yet beneath the surface, the introduction of recall has triggered an entirely different conversation, one centered not on convenience, but on control. Not on productivity, but on privacy. Not on innovation, but on trust. And for many users, especially those who already carry a healthy skepticism toward centralized platforms, recall represents something far more consequential: a tipping point. A catalyst pushing them toward Linux and other open-source ecosystems in search of absolute security control. To understand why recall has become such a flashpoint, it's necessary to examine what it fundamentally does. Recall continuously captures snapshots of on-screen activity. These images are processed using AI models to extract searchable context. While Microsoft emphasizes that this data is stored locally and encrypted, the very concept of a system that persistently records nearly everything displayed on your screen introduces profound concerns. Screens contain passwords, private messages, financial data, medical records, confidential work documents, and countless other sensitive fragments of life. For many users, the discomfort begins with a simple question: why does my operating system need to see everything I see? Microsoft's argument is grounded in a utility. The future of computing, they suggest, is contextual. Machines must understand our workflows, our patterns, our interactions in order to assist us meaningfully. Recall fits into that narrative. It transforms the OS into a persistent observer, one that remembers for you. But observation and assistance are separated by a fine line. The more your system watches, the more it knows. And the more it knows, the greater the consequences if that data is exposed, misused, or exploited. Even if recall's database is encrypted locally, users must trust that the encryption is properly implemented, that vulnerabilities will not surface, and that updates won't alter the rules later. History has taught the tech community that no system is immune to security flaws. Attackers don't need to break global infrastructure. They need only find one overlooked weakness. For enterprise users, this becomes especially alarming. Imagine a compromised laptop containing a searchable timeline of confidential meetings, proprietary source code, and private client communications. The attacker would not need to piece together fragments manually. Recall would have already organized them. The concern deepens when considering the broader trajectory of operating systems. Over the years, Windows has steadily evolved from a purely local OS into a cloud-integrated service platform. Telemetry, account synchronization, mandatory online accounts in some editions, and deep integration with Microsoft services have already shifted the power dynamic. Recall feels like an acceleration of that trend, a sign that the operating system is no longer a passive tool, but an active participant in monitoring user behavior. For privacy-conscious users, this shift undermines a foundational principle: the computer should serve the user, not observe them. This is where Linux enters the conversation not as a trendy alternative, but as a philosophical counterweight. Linux is not merely an operating system. It is a model of transparency. Its kernel is open source. Its components can be audited. Its behavior can be examined line by line. While not every Linux user personally reviews source code, the knowledge that anyone can do so changes the trust equation. Security becomes verifiable rather than declarative. In the Windows ecosystem, users must trust Microsoft's word regarding recall's safeguards. In Linux, users can examine, disable, modify, or entirely remove components they dislike. There is no forced AI snapshot system baked into the core of mainstream distributions. There is no mandatory behavioral capture mechanism running silently in the background. The difference is subtle but profound. Windows increasingly operates on a model of managed experience. Linux operates on a model of user sovereignty. The recall controversy underscores a broader anxiety about AI integration at the operating system level. AI requires data. The more contextual the AI, the more data it must ingest. That data inevitably becomes sensitive. Even if stored locally today, tomorrow's features may demand synchronization, sharing, or cloud processing. Users have seen this pattern before. Features launch as optional, then become default. Data stays local, then becomes cloud-enhanced. Telemetry begins as diagnostic, then expands into behavioral analytics. Trust erodes not because of one feature alone, but because of accumulated precedent. Linux distributions, by contrast, rarely impose sweeping data collection frameworks. Most mainstream distributions like Ubuntu, Fedora, Debian, Arch, and others operate with minimal telemetry. Some include opt-in hardware surveys, but nothing resembling persistent screenshot logging. The absence of forced behavioral tracking is not just a technical choice. It reflects a culture within open-source communities that prioritizes user autonomy. Security professionals often describe Linux as giving users full control of the attack surface. This means you can decide exactly what services run, what daemons start at boot, what network ports are open, what logs are stored, and what software is installed. Minimal installations can strip a system down to bare essentials. Hardened kernels can enforce strict access controls. Mandatory access control systems like SE-Linux or AppArmor can confine applications in granular ways. With Recall, Windows users confront the opposite dynamic. A deeply embedded feature captures activity at the system level. Even if optional, its integration suggests a philosophical direction: intelligence through surveillance. Some defenders argue that smartphones already do far more invasive tracking. That may be true, but desktops and laptops have historically represented a different category, especially for professionals. They are workstations, development machines, creative studios, research hubs. Introducing comprehensive activity capture into that environment shifts expectations. For developers in particular, Recall triggers red flags. Source code, API keys, authentication tokens, proprietary algorithms all can appear on screen. Even if encrypted locally, the mere existence of a searchable visual log becomes an additional asset to protect. Attackers need only escalate privileges to access a treasure trove of contextual data. Linux's modular architecture appeals strongly here. Developers can configure systems without any centralized AI observer. They can use full disk encryption with loop keys, isolate containers with namespace, restrict processes via groups, and audit system behavior with open-source tools. Nothing hidden, nothing proprietary. The phrase absolute security control does not mean perfect security. No system is perfectly secure. Rather, it means control over security decisions. Control over what is installed. Control over what runs. Control over what is logged. Control over what leaves the machine. Recall challenges that sense of control because it introduces a system-level memory layer users did not explicitly request. Another factor driving users toward Linux is long-term predictability. Microsoft's roadmap increasingly emphasizes AI integration. Copilot, cloud inference, predictive suggestions, these are not isolated features. They are pillars of strategy. Recall fits squarely within that trajectory. Users skeptical of pervasive AI monitoring see the writing on the wall. Linux, conversely, evolves through community governance. Features are debated publicly. Code changes are visible. Distributions choose their own directions. If one distribution adopts a controversial feature, others may reject it. Users can fork, modify, or migrate without abandoning the entire ecosystem. That flexibility offers psychological security as much as technical security. Consider also compliance-sensitive industries: healthcare, legal services, finance, defense contracting. Data governance rules are strict. Devices must adhere to rigorous standards. The idea of a system capturing screen histories, even encrypted, introduces additional compliance complexity. Auditors must evaluate storage policies, retention windows, encryption methods, and potential exposure pathways. Linux systems can be configured with explicit logging policies tailored to regulatory frameworks. Nothing captures more than what administrators permit. There is also the matter of threat modeling. Security is not about assuming good intentions. It is about anticipating worst-case scenarios. What if a vulnerability allows unprivileged access to Recall's database? What if malware bypasses encryption through memory scraping? What if future updates expand data retention? In security circles, reducing data collection is often considered best practice. The less sensitive data stored, the less damage possible from breach. Recall moves in the opposite direction by centralizing a vast repository of visual history. Linux users often adopt a principle of minimalism. Install only what you need. Disable what you don't. Remove what you distrust. For some, recall is not merely a feature but a symbol. A symbol of operating systems transforming into data platforms. A symbol of diminishing boundaries between user activity and system analytics. The push toward Linux, therefore, is not purely technical. It is ideological. It is about reclaiming ownership of the computing environment. Open source software embodies a social contract. Transparency enables accountability. If a Linux distribution attempted to introduce persistent screen logging without community consent, backlash would be immediate and visible. Code repositories would show exactly how it works. Forks would emerge. Alternatives would proliferate. In proprietary ecosystems, users rely on corporate assurances. Documentation may describe behavior, but internal implementation details remain opaque. Security researchers have already demonstrated how complex systems can fail in unexpected ways. The more layers added, AI indexing, encrypted databases, snapshot management, the larger the attack surface becomes. Linux's relative simplicity, especially in minimal distributions, reduces that surface. No background AI memory service indexing screenshots. No proprietary black box continuously observing user interactions. Critics of Linux often point to usability challenges. Yet modern distributions have become remarkably accessible. Graphical installers, hardware compatibility improvements, and user-friendly desktop environments like GNOME, KDE Plasma, and Cinnamon make transition easier than ever. For privacy-focused users, the trade-off becomes clear: convenience versus control. Recall promises convenience through omnipresent memory. Linux offers control through deliberate configuration. Some users might argue that recall can simply be disabled, but skepticism persists. Disabled today does not guarantee absent tomorrow. Updates can alter defaults. Corporate priorities can shift. Enterprise policies can enforce features. Linux distributions rarely impose updates that override fundamental user preferences without consent. Package managers show exactly what changes. Configuration files remain editable. System services can be masked or removed entirely. The architecture itself reinforces autonomy. There is also the global dimension. Governments increasingly scrutinize technology platforms. Geopolitical tensions raise questions about data sovereignty. A system that captures detailed user activity may be subject to future legal demands or regulatory pressures. Even if data remains local, corporate obligations could influence feature behavior. Open source systems distribute authority. No single corporation dictates global behavior. Community-driven projects are harder to coerce at scale. For journalists, activists, researchers, and whistleblowers, these distinctions matter deeply. A searchable timeline of on-screen activity could expose sources or confidential communications if compromised. Linux environments can be hardened specifically for high-risk scenarios. Tails, Qubes OS, and other security-focused distributions demonstrate how far user control can extend. Compartmentalization, ephemeral sessions, strict isolation, these are philosophies incompatible with pervasive activity logging. In effect, recall highlights a fundamental divergence in operating system philosophy. One path envisions the OS as an intelligent partner that sees everything to help you better. The other envisions the OS as a neutral instrument that does only what you explicitly command. Neither vision is inherently malicious, but they cater to different trust thresholds. As AI becomes embedded deeper into core infrastructure, users must decide how much observation they are willing to tolerate. For some, the productivity benefits outweigh the risks. For others, especially those steeped in security culture, the risks overshadow convenience. Migration to Linux is rarely instantaneous. It often begins with dual boot setups, experimentation in virtual machines, or adoption on secondary devices. But recall has accelerated that experimentation. Forums and online communities reflect increased interest from users who had previously tolerated Windows telemetry but now view persistent screen capture as crossing a line. Absolute security control does not mean isolation from innovation. Linux supports AI tools, machine learning frameworks, and productivity applications. The difference is opt-in versus baked-in. Users choose what to install. The conversation surrounding recall ultimately transcends one feature. It represents a broader reckoning with the direction of personal computing. As operating systems grow more intelligent, they also grow more observant. And observation introduces vulnerability. For decades, the personal computer was just that personal. Files stayed local. Processes ran without centralized oversight. The shift toward service-based ecosystems blurred that boundary. Linux, rooted in Unix philosophy, maintains a simpler premise. Do one thing well. Compose systems from small, understandable parts. Keep users in charge. Recall challenges that simplicity. It centralizes memory. It aggregates context. It builds an internal narrative of user behavior. For those comfortable with corporate guardianship, this may feel like progress. For those who equate security with minimization and transparency, it feels like encroachment. Thus, Microsoft's recall feature, regardless of its technical safeguards, has inadvertently become an advertisement for Linux's core strengths: transparency, modularity, user sovereignty, minimal default surveillance. In the end, the decision is not about rejecting AI or clinging to the past. It is about defining the relationship between human and machine. Should the machine remember everything you do? Or should it forget unless you tell it otherwise? Linux empowers the latter choice. And as long as operating systems continue evolving toward deeper behavioral integration, there will always be users who step away in search of absolute security control, finding in Linux not just an alternative platform, but a reaffirmation of ownership over their digital lives.